episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor. Welcome, everybody, again to another episode of our show, bringing you another fascinating guest today, helping to create a better tomorrow on many different fronts. Today, we're joined by Dr. Patrick, Director of Artificial Intelligence Research at Volkswagen and head of Argmax, Volkswagen's Group Machine Learning Research Laboratory in Munich, which focuses on a range of research domains, including, but not limited to probabilistic deep learning, optimal control, reinforcement learning, robotics, and quantum machine learning. He also serves as research professor in the computer science faculty at Eötvös Loránd University in Budapest. Patrick previously directed a lab as professor for machine learning and biomimetic robotics at the Technical University in Munich, while leading the machine learning group at the research institute Fortiss, and before that founded and headed the Assistive Robotics and Bionics laboratory at DLR, the German Aerospace Center. Besides from publishing numerous papers and patents on machine learning, robotics, and motor control, Patrick has won numerous awards, including 2013 Helmholtz-Association Erwin Schrödinger Award, the 2014 King Sung Fu Memorial Award, 2013 Harvard Medical School, Massachusetts General Hospital Martin Research Prize, 2018 Webit Best Implementation of AI Award, and numerous Best Paper Awards at various conferences and journals on machine learning robotics. He also serves as a scientific reviewer for various governmental funding organizations, conference and journal boards, is the founding chairman for a nonprofit organization for assisted robotics for tetraplegics, co-founder of various tech companies. In 2018, he started a For Good initiative known as 10 to Go by supporting various teams that are using machine learning to help with the United Nations Sustainable Development Goals. He also initiated ATOMI, which stands for Ethical and Trustworthy Artificial Machine Intelligence, which is a fascinating organization that's partnered up with various multinationals and universities to focus on these topics. Patrick has his master's in computer science from the Free University of Amsterdam, his PhD, University of Amsterdam, computer and information sciences. A lot of interesting topics to talk about today. But Patrick, welcome to our show.
Thank you so much.
It's great having you today. And Patrick, I would love to start things off because, you know, I was looking at your extensive publication record, and, you know, one of the things that popped out at me, and this is going back a couple of decades now, but was your work in this extremely convergent domain. I think the broad term for it is neurorobotics, where you were bringing together various disciplines of artificial intelligence, but also neuroscience, biomechanics. Talk a little bit, because this is an area that even for 2021 seems rather cutting edge, but talk a little bit about the early days, about sort of your initial interest in computer science and information sciences, but also how you got involved in the late 1990s, early 2000s in this extremely fascinating domain of neurorobotics, if you would.
Well, it's very much a story of accidents, positive accidents, I must say there, but when I was in my teens, I had to make the decision either go to university or do music. I played a bit of piano back then. And I think I chose widely because my piano playing, I actually recorded some stuff for a music project we're doing in my lab. Use machine learning to generate some music, but I realized it's a good choice I made because my piano playing really sucks. So I would have been a nasty piano teacher at best. And nobody likes piano teachers, right? So I decided to go in a direction of computer science and mathematics for my studies in the late 80s or mid 80s. And then during that time, got acquainted with two books which were then famous, the parallel distributed computing books. I think they were published in 1986. Nobody knows them anymore. But there were some stories about neural networks and learning and stuff like that. And I've always been interested in biology and in brain and understanding how these things work. So for me, that was a very natural fit. So I started programming neural networks on my desktop computer. Back then it was like 83, 86, and a chip that nobody knows anymore today. But trained those things for nights and nights in my student room, and it was noisy and it was hot and it was irritating, but it was fascinating to see how these things optimize and solve some minuscule problem, right? And you can train that in 2 seconds nowadays, but then it took nights and nights, and it was fun. So it's just fun hacking and playing around with these things. Well, that brought me then to my master's thesis, or the equivalent that existed in the Netherlands back then, where I compared several, I would now say machine learning approaches. Back then we called them neural network approaches for optical character recognition. Mm-hmm. It worked. It didn't work at a level that you can do anything with it, but it worked. And I had my first publication, I think was published in 1990 or something. I made sure that nobody can find the PDF anymore, because it's a ridiculous paper, of course. But back then it was a personal victory, and I went to my first conference, and it was great, and it was an exciting new field, and nobody really knew what's going on there, and we thought we had cracked it. We have found a way of doing something the brain can do, or close to that. Even though everybody knew it wasn't completely serious, but still. A new era of doing computing, of doing information processing, and getting something close to biological intelligence. So great, and then I was lucky to get a position as a PhD student at the University of Amsterdam. I was looking for a job after graduating, going to companies like Philips and Shell and so on, and I found it so boring that out of, well, it was a desperate choice to then do my PhD, not knowing what else to do. So I did my PhD, and that was in a lab in Amsterdam where they had inherited an old robot arm from Philips, and they just had gotten some funding for neural networks from the Dutch government. And nobody wanted to touch a robot arm, so I did. So I'd never seen a robot before, but I started playing with it and started putting it together with neural networks, and I developed some control algorithms back then, and had really, well, apart from the fact that PhD is not fun, but had a fun time doing that and playing with these methodologies, developing some nice algorithms, publishing in hindsight a vast number of papers. I think somewhere between 10 and 20 papers for a PhD is a lot. I think back then it was easier. That must be it. But I learned to do a bit of science. I thought I was never good. I don't think my PhD thesis was particularly good, but it was early, and we wrote a book on neural networks to do teaching at the university. So people still use that book, which is of course completely overhauled, and please don't use it if you find it, but people still do. And as you said, yes, it was early, and that gives some advantage, right? To be not the first one, but among the first ones in the field. So yeah, then all nice, all good. But then came the 1990s, and people realized, well, neural network, you guys promised so much, and this could solve everything, and so far it didn't. We gave you so much money for research, and what applications do you have? Zero. So funding went down, and I moved to the German Aerospace Center in the meantime. After my PhD, I think I did a 1-year postdoc at the University of Amsterdam, but then I moved. Because it was like the best robotics lab in Europe back then, and I went there in a group of engineers and mechanical engineers and electrical engineers and control engineers, and here you are, the only computer scientist, in a weirdo in this group of, I don't know, something like somewhere between 30 and 50 people. Yeah, whatever they can do by modeling the robots and perfect control and complete controlled environments, I can also learn with a neural network, except that, of course, I need the training time, and I need to be happy with an accuracy which is not 1 millimeter but 1 centimeter, right? That's the kind of comparison we have. So you're completely lost in such an environment, which is what neural network is not made for. They're not made for replicating something that you can already do. They're made for doing something you can't do.
Right.
And that didn't exist in robotics back then, because we didn't have the sensors, we didn't have the compute power, we didn't have the problems, we didn't have the applications. So that, with the fact that machine learning funding was running dry, this was mid-90s, early to mid-90s, people going to support vector machines instead, which have all but disappeared at the moment, and other methodologies I was not a big friend of. I was then already so long on a path of robotics, understanding robotics, and understanding also the difference between robotics and biological motion, which is something as comparable as a neural network in the brain is, right? It's something completely different, but there are inspirations in some directions. As that lab, I was focusing a lot on manipulation, on arms and hands, later also locomotion, but then mostly arms and hands. And the behavior was not even close to what humans could do. I started to focus on that. So yeah, right. I understand the brain in many quotes. Of course, I don't understand the brain, but you know what you can do and cannot do. And you understand robotics, but why can't we make robotics, even with those fancy control methods and computers, which are very fast in comparison to the feedback loop you find in biological systems? Why can't you make the behavior even close to what humans can do, or what biological systems can do? So that made me interested in biomechanics, right? Understanding muscles, understanding the tendomuscular structure in an arm, in a hand. Also look into tactile sensing, right? The tactile sensing in our fingers is a key thing in our manipulation, and is a key advantage in how our brain and our hands co-developed. And then also yes, how can I do the control of that? How can I replicate this intelligent, embodied intelligence, right? You find in biology. How can I replicate that in a robotic system, or at least the principles of it, and then use that to get much better, faster, stronger, dexterous manipulation approaches. We went a pretty long way there, and up to a certain level that worked, with the huge caveat that yes, it's great, and yes, we can do great stuff, but you always have to put an engineer on the side, and it's never close to a robustness you would need to make it into something useful and tangible. So a research project par excellence, I would say, and great fun and a lot of insights and so on, but that last step that you need to do, it's not there yet. And I'm sure it will come, but I can't tell you if it's going to be 10 years or 50 years.
Got it. No, please.
Yeah, so yeah, I can go on a bit. That brought me to also then understanding, well, okay, you've got the brain and you've got the body, and they're together, right? You can't separate them in one way, not conceptually, not in any other way as well. And on the other hand, I've got my computer and my robot arm, and they're completely separate. So what cross correlations can you do? So that also made me interested then in brain-machine interfaces. So how can I use my robots to assist, I don't know, tetraplegic people or whatever situation you want to look into. And that was around the time I started my Bionics group at the DLR. I think in the end we were something like, I don't know, 7-8 people or so. And we looked into things, well, apart from tactile sensor, we developed a tactile sensor, which made it into a startup. But we looked a lot into brain-machine interfaces, in how can I get signals from the human body in order to create, to control an assistive device for that person. And it was a lot of fun. It was very interesting. We understood a lot of topics of EMG, so electromyography, so reading the activity of a muscle by putting a sensor on the skin. We developed absolutely a novel methodology for that, making it much more robust. So that was pioneering work, and also one of the best cited papers I have. We did that also a bit for EEG. So you put your sensors on your skull and you try to read what the brain does, but not very much. But then we had a nice collaboration, which I initiated with Brown University, where we looked into how can you go a step further, because they had patients with implanted electrodes in the skull, in the motor cortex. So operation, you open the skull, you put in this sensor array, this electrodes in the motor cortex, you close it up, and it's permanently there. Permanent meaning over a period of years. And they use that to do a bit of computer control for tetraplegic people. So they control the cursor of a mouse in order to move and to click and maybe type an email or something like that. Difficult interface, but much better than nothing at all. And so I approached him and said, well, can't we do this for robotics? So we sat together, and I think we did a pre-study, and then this first study and second study, 3 years of work approximately. And in the end, then we managed to have a robot arm, one of our robot arms, and a hand controlled by one of their participants in that study. And she was able to then, in a demo, grasp a cup and move it to her mouth and drink from it, by just imagining doing the movements herself with her hand. So a relatively natural interface, not completely natural, of course, not far away, but a relatively natural interface. Beautiful work, also great paper, right? We made it to Nature with that one, which was wonderful. But there's a big but after that, because then study is over, everybody goes home, everybody happy, except for that participant, I presume. I mean, I never talked to her anymore after that. But of course, it's a bit frustrating to have a high impact scientific work and the follow-up is not really given. Mm. So that made me initiate one of the things you mentioned when you read my CV, the non-profit organization for tetraplegic or for assistive robotics. Mm-hmm. I'm ashamed to admit that never went anywhere. So it was 7 people. We started it off and we had great plans and so on, but in the end it just died out of despair because, well, none of us really put in the time we should have in order to do that. So that was discontinued. But we did have quite some collaborations with 2 SMA patients in Germany. SMA is spinal muscular atrophy, which is a disease that probably destroys the alpha motor neurons in the spinal cord, so you can't control your muscles anymore. And we interacted a lot with them, did a lot of work with those 2 women together in creating interfaces for them, understanding the disease, working also a bit on helping they had a program where they used some medication to reverse their disease, and we developed some methods for the quantification of how well that methodology worked. So that was nice, small step, still in the pipeline, but currently quite quiet. But that work is done. Well, we did a lot of stuff there. Also a bit of stuff on prosthesis, hand prosthesis, and leg prosthesis, a bit in biophysics of the human body. So how do you use your body? How do you use your muscle control and stiffness control in manipulation and walking? So wonderful time. but after, I don't know, 5 or 7 years, I get bored with the topic typically. So I went back to machine learning in around 2008, 9 or so. It was becoming big again. So then I went to Technical University of Munich and started a lab there on machine learning and robotics. And we did a lot of stuff on probabilistic machine learning, which is like the first word you mentioned in your introduction, and people will not understand what it means. But in a nutshell, it means that you don't just want to explain a behavior, but you also want to explain how sure you are about your explanation. Right? You don't want to give an answer yes or no, but you want to say, well, think yes because 75%. And there's a whole body of theory behind that, wonderful body of mathematics which all supports that, and which is not computable. The whole statistics is typically not about computing it, but about mathematics. But machine learning puts a computability on top, so you have a wonderful way of using mathematics, putting it in the computer, and doing great ways of describing data sets and using those. I took half or 3/4 of my university lab then to Volkswagen in end of 2016, and here we are now, having continued much of the work we started back then, and using that to do time series prediction. So I observe a process and I want to know what happens in the future, but also to use that to optimally control these things, and that's where we are right now.
Yeah, I wanted you to go into that because I think it highlights, well, one, no, Elon Musk didn't just think of this stuff a couple of years ago that you were a few decades back, but it just really the broad spectrum of everything that you've been involved in to date, Patrick, which is fascinating. So here you are now with your team at Volkswagen. I think the lab used to be called Data Lab Munich, now known as Argmax. Once again, involved in a wide range of topics, and I guess we think Volkswagen, we think automobiles and self-driving cars and things of this nature. But once again, I was looking through some of these publications, and I see things on here like adaptive mechatronic exoskeletons, quantum neural networks, and then there's as you were just saying about probabilities. There's a paper here about estimating type 1 supernova explosions. I hope you don't know things that are going to be happening on that domain anytime soon. But talk about a little bit about the organization, why Volkswagen set it up, sort of where your directives come from. I mean, did you get, hey, study supernova and then look at these self-driving cars, or how does this all work? And what's the Argmax all about?
Okay, now you must understand one thing. Volkswagen is a big organization, right?
Sure,
670. I saw a new number recently: 674,800 employees. That's from last week, as far as I know.
That's a lot.
So it's big. And of course it's archaic, right? It's been growing tremendously in the last 50 plus years, 70 years, whatever. And as these organizations go, things go wrong all the time, and you have to repair them all the time, and so on and so forth. So introduction of a new technology in a company like this, which is traditionally built, well, initially on mechanical engineers and later electrical engineers, now introducing something like software in an organization like that is a complete change of mindset, right? And the understanding that you need to have software in a car is actually shockingly new. But it's necessary because right, the driving iPhone, I don't like that metaphor, but it helps a bit perhaps to know what we're talking about here.
Sure.
Most cars you get in nowadays, the software is quite disastrous, right? We all fight that. So that needs to be taken care of. And what Volkswagen did in 2013, 14-ish, is create a lab which looks into data analytics in order to optimize some of the company processes. And data analytics means I get a data set, and I can use that data set to predict something or to automate some kind of process, and so on and so forth. So that was set up, and yeah, very nice and very useful. And yes, you could do a lot. But that lab that was created back then lived on showcases, so showing that you can do this kind of development, and that you could save I don't know, 10 million here or 100 million there if you would actually implement that. But that's still very far away from actually doing that. Now, and the realization was that basically you have to do the whole development from research up to R&D, up to D, up to development and deployment after that, right? So you have to do the whole thing, and so that was why they approached me and asked me if I'm interested in taking over the research part, and to see how the methodologies we develop can actually help into, first of all, putting this kind of knowledge and this kind of mindset into the company, but on the other hand, also, of course, then see how we can develop methodologies which can be used. Now that's now 5 years ago, or a bit over 5 years ago, and right now we're in a situation where, well, we have a number of labs on different topics, but also one or two on applying machine learning methodologies in the company. And in front of that is my lab, which does the fundamental research. We are completely independent in the topics we look into, what kind of work we do. So I with the people in my lab, we determine, well, this is interesting, this is what we want to do, and so on and so forth. We develop the methodologies, we look into the applications. If there are applications in the company where our methods are useful and solve a problem, then we are happy to assist the other ones with the methods, do a proof of concept, then hand over and support them in the deployment of a method in some kind of setting. We're currently working on 3 applied projects at the same time, which is not very much, but it's more than we actually want or were set up to do. But it means that something like 90% of the effort in my lab goes into fundamental research. So that means doing the stuff we like to do and we think are relevant, publishing papers. I find it extremely important that those things then are also validated in the lab. So that's why I have a robot lab. We have a number of robot arms, we have drones, we have walking machines, and other things. And we put those methodologies, we validate them on our hardware, and if they're good enough, which are typically not, but if they're good enough, then all right, it's check mark. Typically they're not. Typically we have to then go back and spend another 3 months or 6 months or a year or 2 years or 5 years, whatever is necessary to make the method widely applicable in quotes. And in the meantime, right, if there is an application, as I said, in the company, then we are happy to support that. At the same time, we also do training within the company. So we train PhD students or employees who need these methodologies and say, well, do an internship in our lab for 3 months or half a year, and we'll teach you what you need to know. So all of these kind of exchanges happen. So it's really a bit of a think tank, which is almost completely free in the way it operates.
And you know, we need to do this fundamental research. I mean, I think the concept that a Volkswagen is willing to invest, not just obviously in their core business, but in all the possibilities here for artificial intelligence, machine learning is a breath of fresh air in many ways.
It's nice, and it's perceived very, very positively inside and outside. In the beginning, it was like, what the hell do you guys do here? But people got used to that, and they understand the value in general, and that we also do music generation and also do supernova analysis, and also do spinal cord analysis and other things on the side. That I think that's only positive, and I think it's important to
absolutely
also do other applications which are not automotive or anything like that. And in reality, it's just because I like to do it.
No, that's cool, and they let you do it, which is great. But Patrick, alongside that work, you've also launched this 10 to Go initiative, which has brought together Volkswagen, a very large company, with this other large company, Microsoft, and we've had several guests from Microsoft on the show talking about artificial intelligence, mainly in healthcare, but we talked about drones and agriculture and the environment a bit. Talk a little bit about 10 to Go, and then also you organize these what you call think-a-thons, different collaborative platforms to look at these United Nations Sustainable Development Goals, whether they're poverty, hunger, inequality, and so forth. Talk a little bit about how you put this together as well with all your other responsibilities, and how you married sort of the worlds of Volkswagen and Microsoft to push this initiative forward.
Okay, so imagine you are a researcher, right? And that means if you are in public institutions, which I was all my life, that means that yes, you're a researcher, but no, you don't get money. So every money you need to have to hire people, to buy equipment, whatever, you always have to earn in one way or the other. And earn means getting some public funding, third-party funding, typically through national governments or through the European Commission or whatever. To fund your research. And then you have this project, you write your project proposal, you do 3 years of project management and the research, and then you need to get 2 other projects to follow up because you have hired those people and their contracts extend the previous, and so on, snowball. That's nice in the beginning, but in the end it's tedious and a disaster, and eats away 80% of my time as a professor. I'm not suggesting a better model, that's not the point here. But now I came from that in an environment where I have funding from a company, which is a generous amount of money and a fixed amount of money with which I can, well, in quotes, do whatever I want, right? So I can spend it on my research quite liberally. So yes, of course. Now, I had this mindset change of I'm spending public money on my research, to I'm spending private money on my research. So I feel that I not only should give away to society, give back to society what I've gotten before in terms of publications and research output, but I should do a bit more. Now, so I got in touch at the United Nations General Assembly 2017, I think. I was in New York there, and I got informed about the Sustainable Development Goals, right? Those 17 goals by the United Nations, which are the goals which should be solved by 2030. If not, it's not realistic, but it's the path that counts, the way that counts. So I said, well, all right, I'm now in this big company and I have my budget, so why shall we not try to address these, even in my mini budget situation compared to the whole of the company, see how we can sustainably address those. And I thought, well, the best thing to do is to say, well, let other people solve that, but I'm going to support them with 2 things. First of all, know-how, and secondly, a bit of a budget to start up their company. There was a lot of hassle and a lot of thinking and so on, but I'm not the kind of person who first go to the CEO or CIO to ask for permission. I just do it and I'll solve the problems along the way. So I said, okay, we're going to do this, and we're going to call for participation. And then somebody from Microsoft came to me and said, hey, I'm hearing you're doing this. Isn't that wonderful to collaborate on that? Because we'd like to get involved there. And I said, sure, why not? So we did a 50-50 arrangement, each paying 50,000 euros into the pot for the winner. Nobody else getting any money out of this. We got a lot of volunteers to assist in coaching the teams. We got a lot of volunteers in running the events, in being in a jury, and so on and so forth. And in the end, we hosted 20 teams. I think we had something like 80 odd applicants in our queue. That was really a nightmare, because we had set a deadline on 31st of December. It's stupid, right? Who puts a deadline for application 31st of December? Because then you have to spend half of your Christmas holiday on watching who's applying. But anyway, that was stupid to do that. And most people applied the last day before the deadline, so went up from, I don't know, 20 applicants to 80 applicants in like one night. But we selected the teams, and it was, for me, explicit. I explicitly said we have to be open to which of the SDGs. So it can be anything. It can be equality. It can be hunger. It can be water. It can be energy, it can be transportation. I explicitly do not want to restrict it to transportation, right? Because it's Volkswagen. Cool. I think our societal responsibility goes beyond just that single topic. So set up this event, and thanks to the wonderful collaboration with Microsoft, I must say that here, that's not just a sentence I'm saying here, but it went very nicely. We both did a lot of work in selecting the participants, setting up the whole scheme. There was initially we wanted to do 1 weekend of hackathon, but it went to 1 month of thinkathon, because everybody had to do remote, and which was actually much nicer because we had participants from all over the world. All continents were represented. And in the end, well, we found a winning team, which is looking on a much simpler scheme of trading CO2 certificates, and also measuring CO2 absorption of forests. So that's where we are now. We just had the first review of that team. I think it was last week. And they're successful. They then afterwards, because we basically formed the team through 10to-go. They weren't anything before that, but formed together because of that. And they got another award, and they got another investment. So they have a few 100,000 to start off with, and are now looking for seed investment and so on to kick it off. So it looks that exactly that happened. What I wanted to happen is make something more than just a weekend of people hacking. It's something that can actually, even though it's a very little bit, but can actually change something.
Absolutely, absolutely. And in addition to 10to-go, you also, and this one really speaks to your ability as a coalition builder, you set up a TAMI, ethical and trustworthy artificial and machine intelligence, bringing together, to list Volkswagen, of course, but Deutsche Telekom, Siemens, ABB, multiple universities, with this goal: develop actionable and measurable guidelines to satisfy these ethical principles. I heard you in a presentation, I think a couple months ago, you said they're making sure stupid things don't happen with these tools. Talk a little bit about Atami and a little bit about what you are specifically working on and concerned about in terms of some of these issues.
Yeah, thank you for that, because it gave me a lot of sleepless nights, that one, but we've got it covered so far. Something that I started, I think, in 2017. I was talking to my CIO back then, and we were talking about trust and ethics and AI, and there was becoming a bit in vogue there, right? Company like, I don't know, Google and Apple and whoever put codes of conducts on their websites. Our AI systems will not discriminate, la-di-da, the whole list. And he said, well, we should join one of those organizations. And we looked into that, and they sent a bill of $400,000 or euros or something like that, for just being in there and putting that code of conduct on the website. And I said, well, yeah, okay, it's maybe not much money for you, but I'm Dutch, so I grew up with the feeling of you have to spend your money wisely. I can do that better than they can. That's what I told him. I said, okay, well, go ahead, have fun.
Thank you.
Yeah, stupid thing to say, right? But I thought that, well, a code of conduct on your website is very nice, but I, as an end user, do not trust such things. If a company says we will stick to these principles, it's not that I don't believe they don't want to, but I don't believe that they can in some way. Because if you have a list of things like my software does not suffer from biases, what does it actually mean? So how can you make that promise actionable? So go back to your researcher, your developer, your programmer. What does this person have as an indication for their daily work? That it means I should not put a bias in my piece of machine learning, right? That doesn't trickle down there. So I decided to set up not a code of conduct, but a way of making codes of conduct actionable.
Okay.
So a transition from ethical framework to a set of actually it's called standards and a certification of that standard, right? You have to understand what these things mean. It took me a while as a computer scientist, mathematics background. It's not the stuff one likes to talk about, but it boils down to creating processes of software development which adhere to specific standards. Mm-hmm. And once you have a standard, you can actually measure that. So that's the certification of a standard. You have ways of measuring if people stick to that standard in order to make sustainable software development. And then once you make sustainable software development and you define a clear process for doing that, then you can put things like ethically correct, bias-free, and so on and so forth on top of that. Then you can start measuring those things. You can't prevent them, but you can try to prevent them. And if they occur, you can measure that they did occur and take action. Right? Because the difference between traditional software development and machine learning-based software development, in traditional software development, you define your requirements, you write them down, then you go to your programming shop and they devise a piece of software, it's according to some scheme, and then in the end you do the testing, and then it's done, and then you put it in operation. If you do this for machine learning software, it's totally different. No, it's not totally different. So the scheme, the definition is still there, and the software programming is still there, but there are two new things. First, the data curation comes in there. So how do I get my data? How do I pre-process my data? How do I measure the quality of my data? And that interacts, of course, with my software. But then a fourth very important component comes in, which is supervision of the running system. So when a system is running, and you haven't been able to completely ensure that your data is correct for what you're using it for, because there might be a bias in there which you were never aware of, but it's there, then you still have to make sure that while your system is operating, it does what it is intended to do. So you have to continuously guard that, and then go back into your feedback loop of data curation and programming and stuff where necessary. Mm-hmm. So that's the model we're developing with those 16 other partners. You mentioned a few of them, and that's extremely complex. But we have cracked, I think, 3/4 of the principle right now. I think we will come forth with a set of initial set of guidelines and process at the end of the year. That's currently in the making, and then start doing that more sustainably in a larger organization next year. Mm. But it's this being dissatisfied about things and hoping you can do it better that sometimes brings me to those silly ideas. Yes.
Yeah, nothing silly about it, and it's these new models that ultimately create the future, and yeah, it's extremely fascinating. One other new model, I say it's a new model, but it's it's down this path. Another thing you've talked about, I've seen some of your presentations. You're a proponent of open sourcing. Argmax has put together this really, you termed the inverted classroom approach, Technical University of Munich Informatics department. Talk about, because you put all this course material out there, I feel like I can go study today and become an expert and come work with you. But let's talk a little bit about what that particular program is about and how it was set up.
Okay, so that was from my days when I was professor at Technical University of Munich. Yep. I started off with a class of machine learning. I inherited for somebody else, and I think first year I gave it was 2011, must have been 11, and we had something like 30 students. And it was cozy, it was nice, small classroom. You could do the teaching, and people ask questions, and so on. All wonderful. We made it very mathematical, very little applied. So you have to have this interaction if you derive equations and try to explain that to people. Now the next year, so that must have been 2012, I think we had in the order of 60 students, or maybe 80. It was getting cramped. In the last year I did that, I think that was 2017, we had 600 students. So in a class of 600 students, you can't go to the blackboard and write down your equations and shout what you're going to do, because 95% of the people are just sitting there because they think they might pick up something, but there is no way of interacting with the students. So we had to take care of that, and I already in 2012 or 13. Found, because you give those people an exam, so you get grades and stuff like that, and you see quality deteriorating, even though you have the same program, but people stop being able to follow you. So we said, okay, let's do it differently. Let's give them a video of the stuff that we would play otherwise in front of the classroom. Go through the slides, do the derivations and stuff like that. Give them the video, and then they can ask questions during the classroom. So you give them video, I don't know, 2 or 3 days before the classroom, and then everybody is free to ask a question. So we did that, and then you go to class, and then nobody asked a question because nobody watched the video, because they didn't really see the reason to do it at that time. They had something better to do for another class. Right, so we had to incrementally develop a model of how to force these students, and it's last semester master students so these are grown-up people, right? But of course they have their priorities. I understand that. So you have to force them through homework and extra credits and stuff like that to follow that, to go into those videos and understand the material before they come to class, so that they can actually ask questions and can have a dialogue. Took a while, but I understood the model in the end, and I understood the priority of the students in the end, and it worked very nicely. So we're actually doing that now for another advanced class. The one you saw is a beginner's class. And we've now an advanced class on variation inference, which is a technique in machine learning and robotics, how you can use probabilistic neural networks in robotics environments. And that's actually a lot of fun, because it's a small class with only 20 students. So it's very nice to do teaching, because you get people interested in the stuff and understanding the stuff and asking the questions. And you always have, out of a class of well, you get 75% of the people who just do it for the credits, but you've got 25% who are interested and see that as a new career path. And that's also how I built up my lab to a large part. So I think, well, I didn't count, but say roughly half of the people I have in my lab started as a bachelor or master student, and then did their PhD with me, and then stayed on as a permanent employee. So I think the oldest one has been here with me for 10 years or something like that.
Outstanding. Patrick, a couple of weeks ago, actually maybe about a week ago, here in the US, there was this big report. It's been all over the press. It was done by the United States National Counterintelligence Security Center, that falls under some component of the Office of National Intelligence here, which identified these 5 key areas: artificial intelligence, quantum computing, biosciences, semiconductors, and autonomous systems as sort of key for the future. If we're not supreme in these areas, that we're in big trouble as a country. They kind of seem to be areas that you were working on 20 years ago in the neurorobotics space. But take us out a bit, if you would. I'm sure these 5 areas are critical for all countries and for what's going to be happening in the coming decades. But what else gets you excited in this domain? Coming back, as you come back to this sort of convergent theme, whether it's neurorobotics or whether it's other interesting combinations of these tools, what gets you excited looking at 2025, 2030? Where, if the CEO of Volkswagen came to you and said, okay, you're in charge of all this stuff now, just run with this company any way you want to. Where are you taking things?
So if you restrict the question to the scientific domain, I wouldn't know an answer, to be honest, because there is so much stuff out there. There is so much stuff with respect to solving computation. Right, computation is really at its beginning. I have the feeling. Quantum computing, I don't know if it's going to take off. It's fun. It's a possible way of doing much more efficient computation of probabilities. It might take off. It might also not. But changing the computation, which is now, right, Moore's law is flattening out right now, and we need to take care of that as the complexity and the possibilities increase. So I think that's fascinating. But I think also anything related to the understanding of the brain is a key thing, because there is an efficiency in the brain, even though it's extremely slow. Right, it's extremely slow compared to any compute system that we work with nowadays, and it has the same capacity in terms of operations per second or storage capacity as a computer has nowadays. A bigger computer, but still. But we are not even close to understanding how the learning works in these systems, and how that can be so extremely time efficient, energy efficient, and incremental, right? That's also one of those problems. When we do machine learning, we take a problem, we train the hell out of it, and it works well. But then tomorrow we take a new problem, we train the hell out of it, and it works well again, right? But the brain doesn't do it like that. So the brain has a way of creating controllers of body motion, but also of interaction with the environment, that are very efficiently and quickly trained overnight, or in the course of several nights, to solve those problems. And the way we deal with that in machine learning is really increase the size of the hammer and you'll get closer. But right, more compute power, you go faster. So we're doing so many stupid things there. Robotics is the same thing. We're doing so many stupid things there, and we are blind to it. So I would actually love, but and I dare to say that because I think nobody of those people will watch this video, but I would love to reboot the neuroscience community, because I'm not a neuroscientist, don't get me wrong, people, please, but I'm collaborating with many neuroscientists, and I understand that neuroscience suffers a lot from many old-fashioned concepts which may not agree with what's really going out there. And they certainly not agree with the way people like me in machine learning understand how data processing goes. I think there's quite a big difference there, and I think we should focus on that. I'm trying to, but it's a handful to also try to make a point there. Robotics, same thing. Things are advancing there, but you know, when I first joined the DLR, which was end 90s, people said every 2 years, I heard the sentence, well, in 5 years, everybody will have a robot at home. I've really literally heard it every 2 years, that sentence, and we are not even close, right? I mean, if you don't count those vacuum cleaning robots, which are, well, okay, yeah, maybe, but That's not really what we meant. So why does it take so damn long? Why does it take so damn long to have machine learning take off in a much more impactful way, right? Machine learning or AI was a big hype starting 2000 and I don't know, depending where you look in research, 2010 in companies maybe 2015 or something like that later. But right now it's flattening out a bit, right? The big news is gone. So why can't we make this damn thing stick and make it much more sustainable? So that was also for me, right? This ATAMI thing that we talked about. That was for me to prevent another damn AI winter coming along, because I want things to be sustainable and let's do it right this time. And it means that you have to sometimes take a step back and don't just look at what this great algorithm can do, but then actually also make it do that. Actually also make it work. And I understand now that that's a very, very, very big problem, but I am in a position where I could do that. So if the CEO would come to me, I would say, well, damn it, I want a budget of I don't know, 200 million a year to start off with. And let's build up a unit with a few thousand people, but not in 1 year, please. And let's roll these methodologies out, because I think I know how to do that, at least in theory. I'd have to learn in such a size how to actually do that. But let's start developing those methodologies and roll them out in a sustainable way, so that it actually adds some value to the operation. And that value won't come in 2 years. That value will come in 5 years if we're looking. So you need to bear with us. And Amazon, right? Great example, does it like that.
Yep.
Even though it cost them 20 years, but still, doesn't matter.
Hey, if we can get the ball rolling, though, the sentiment about these cycles, and as you mentioned, the AI winter, we want to avoid that again, especially if groups like yours are you're moving. We got to keep you moving, and it's fascinating. The whole
I'm on a tanker and I have a paddle in my hands, right?
Exactly. Patrick, what do you like to do for fun in your off time? Are you still trying to make music, or
I'm still playing my piano, yes, of course. Okay. I'll never stop doing that. Working on Bach partitas at the moment, and I actually want to play all Scarlatti sonatas, which is 560, until they discover some new ones. I did the math. It's going to be tough until I will drop that. So at the rate I'm going right now, it doesn't look good, but never give up hope.
No.
Yeah. At the same time, I like to be competitive in sports and stuff like that. So I like to do that. It's getting increasingly difficult as the years pass, but that happens also to the people around me. So I'm pretty safe there. It's good. So
outstanding.
So that kind of stuff is my hobby. Do a bit of woodwork at home and things like that.
Excellent.
Play with the kids.
Oh yeah, we will have to do that. That's really great stuff, Patrick.
We're in Swedish at the moment. That's a bummer.
Yeah. Okay. No.
Why not Swedish, right?
What's that?
So I'm learning Swedish, and I said, why not Swedish?
Yeah, why not? Why not? Yeah. really fascinating set of programs. And I'm rooting you on, Patrick, to keep these various unique models moving forward. We definitely need them on all of these fronts. For everybody that's going to be listening to this particular episode of the show on the podcast networks or watching on the YouTube channel, you've been listening. Dr. Patrick, Director of Artificial Intelligence Research, Volkswagen, Head of Argmax, the Group Machine Learning Research Laboratory. Definitely, he's also a research professor in computer science at Eötvös Loránd University in Budapest. definitely check out 10 to Go and their fascinating work on the United Nations Sustainable Development Goals, also Atomy and everything that they are focusing on there with regard to ethical applications of artificial intelligence. Patrick, I want to thank you for taking time out of your schedule to do this. Obviously, thank you for everything you're doing there.
Thank you very much for the invitation.
Yeah, and thank you, as we say on this show, for helping to create a better tomorrow via what you're doing. Really very fascinating.
We should never stop trying, right?
Absolutely not. Be well.